Welcome to qnawire.
So we're doing chapter 18, problem 49 here. So part A says, show that the number of collisions a molecule makes per second, called the collision frequency, which we call F, is given by V average over this, for the mean free path. And if we reevaluate that, that is the same as 4 root 2 pi r squared V average in all over V. Okay, so this is what we want to show. And to start this, we can think of the average speed as the molecule as v bar. Then that means the average time between collisions is the mean free path divided by that, right? So this gives us our distance over velocity, gives us a time. And if we want the frequency of that, that's just 1 over the time. So this is the same as 1 over delta t average, or v bar over ln. And as we can see here, we already know that v bar over ln is the same as 4 root 2 pi r squared v bar in over v. It's as simple as that. Cool. Let's move on to part B. So part B asks us to figure out what is the collision frequency for N2 molecules in air at a temperature 20 degrees Celsius and pressure of 1 times 10 to the negative 2 atmospheres. Okay, so first let's figure out what the mean speed is, and that's given as 8 kBt over the pi times the molar mass. So this is 8 times 1.38 10 to the negative 23 times 293 Kelvin all over pi times what is the molar mass? Actually, let's go back. Let's not calculate this yet. We don't need to. Let's plug it in. Okay? So we know that the frequency here is given as this. So let's separate the v bar out and plug what we have for that. So this is 4 root 2 pi r squared n over v. This is times v bar, so that's 8 kBt over pi times n. Okay, so let's simplify this a little bit. We don't know N or V, but we know from the ideal gas law that P over kBt equals N over V. So let's simplify this more. So this now becomes 16 so 16 and what does all cancel out? So yeah, 16 is this combined with this and this. Let's write that out. And then we also have pi r squared, and n over v is p. So we have a kBt on bottom, and we have the square root of kBt over pi n. So we can simplify this even more. This is 16 r squared p times square root of pi over n kBt. Okay. So now let's calculate this, because this is going to be much easier to do. So F now is 16 times 1.5 times 10 to the negative 10 meters squared times 1 times 10 to the negative 2 times 1 point. This is the conversion factor, or this is what the pressure in atmospheres, and then the conversion factor to SI units is 1.013 times 10 to the 5 pascals. Okay, and So that's 16p r squared times square root of pi over 1.38 times 10 to the negative 23, and then times 293 Kelvin, and times the molar mass, which is 28 grams per mole, and then convert to kilograms is times 1.66 times 10 to the negative 27 kilograms. Cool. So we should have everything in SI units here. So plug in our calculator and we see that F equals 4.7 times 10 to the 7 collisions per second. Awesome. That's it.